Now we want to turn our attention to outliers and how to identify them, which is going to involve our upper and lower fences. I have here my raw data and some box plots for the points scored by the Middletown High School's football team in 2018 and 2019. And I need to use this formula, first quarter minus the interquartile range times 1.5 to find lower fences, and this formula, the third quartile plus the interquartile range times 1.5 for my upper fence to determine if I have outliers in either of these years. To do this, of course, I need to know my quartiles and my interquartile range. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pieces of data, which means my median is at the 6th. 1, 2, 3, 4, 5, 6. So here are my medians, and that is also my second quartile. So then I can find my first quartile as the middle of this first half, and my third quartile as the middle of this last half, which can now help me to find these things. For 2018, my interquartile range, IQR, for 2018 is 28 minus 17, so that is 11. And it is 25 minus 17 for 2019, so that is 8. 25 minus 17 is 8. So now that I have found my IQR and my quartiles for each of these, I can check and for outliers. So I'm going to use blue here for 2019. And I will stick with purple here for 2018. So in 2018, my first quartile, 17, minus my IQR times 1.5. My IQR is 11 times 1.5. Pulling up my calculator here, I have 17 minus, don't lose your parentheses, 11 times 1.5. That gives us here 0.5. So if we look here, we do not have any data points in 2018 that are less than 0.5, so we don't have any outliers on the lower end. Let us check the upper end. Our Q3 here is 28. So now we want 28 plus our interquartile range times 1.5. That gives us 44.5. We do not have any outliers in 2018. There are no data points above our upper fence or below our lower fence. Let's do the same thing here for 2019. For our lower fence, we are going to want 17 minus our interquartile range here was 8 times 1.5. We have 5 here as our result, so that equals 5. And that does give us an outlier here because 0 is less than 5. Let us check our upper fence. Now we want 25 plus our interquartile range is 8 times 1.5. This gives us 37 here. And once again, we do have an outlier, this 45. So with that, I am going to recreate, just so that I can look at it, my 2018 graph. So for 2019, my lower fence was 5 and my upper fence was 37. And I had two outliers. I had outliers at 0, which was below my lower fence, and 45, which is above my lower fence. So now I need to work with this data set ignoring my outliers. Since I have one outlier on each side, I now have 9 pieces of data, and my median has not changed. However, now I'm going to find my first quartile here, so that is going to be 17, and that has not changed. My third quartile now is going to be 24 and a half, so that has changed slightly. It's 24 and a half because it needs to be between 24 and 25. So my minimum is now 7. My second quartile is 17, between 17 and 17. My median is still 24, and my maximum is now 27. Please review the previous video if you don't remember how to create the box and whisker plot. Now that I have created my new box and whisker plot, I can again analyze this data set. With the outlier removed from my 2019 data, I can now see that 50% of the data falls between 17 and 24.5, which is here in my interquartile range. And the median is, as we said, 24. 2018 was a better overall year in terms of points scored. One thing I have not plotted yet are my outliers themselves. So my outliers I'm going to plot by showing a little dot or asterisk on my number line where each of those outlier points are. So just to finish up, and notice that everything is already labeled. Don't forget to plot those outliers here with your box plot and complete your new comparison without reference to the outliers.